Hi, this video is going to cover scatter plots and the line of best fit. The learning goals for this video are to be able to create a scatter plot from given data by hand, to describe the relationship between two variables, draw a reasonable line of best fit on a scatter plot, and also to use the line of best fit to make predictions effectively. So we're just going to start with a question here. Is there a relationship between the Olympic gold medal winning times in the men's 100 meters and the year of the Olympic Games? Like, are they tied together somehow? So here we have data from Wikipedia. It talks about the last 10 Summer Olympic Games and the winning time for the 100-meter dash for men. And I've just set up a quick axis here. We got year on the bottom and the gold medal time here on the y-axis. So we think that maybe gold medal times depend on the year of the Olympics. So gold medal winning times is what we call a dependent variable. Okay. And what that variable we think depends on, we call it the independent variable. Now the independent variable, I'll just write independent. The independent variable is always on the x-axis here, and the dependent variable is always on the y-axis. So what we're going to do is we're just going to plot the data on this grid. So in the year 1976, the gold medal time was 10.06. So I go to year 1976, and I go up to 10.06, which is right over here, just above 10.05. In 1980 here, this is 10.25, so 1980 is over here, 10.25 is up here, and then in 1984 it was 9.99, so 9.99 is really close to 10.0. So those are the first three dots. Not like a really good cooking show, I've done the rest. So as you can see, these dots, I mean, except for that one up here, they all seem to be going downwards like this. And that's a clear pattern that as the years increase, okay, over time, the winning times for the 100-meter dash for men go down. So what we're going to do is we're going to make that pattern really clear by drawing a line kind of through this pattern here, kind of like where I'm moving the mouse cursor here. So I'm going to go draw that line, probably starting from here and drawing a line to model that pattern that I see here. So as you can see, this line goes in the same direction as the trend of the dots, which is going downwards here. And this line, there's more dots. There's some dots above and some dots below. That's fine. Normally we have a computer to do something like this, but we're going to do it by hand. So I can see here that as the year goes on, right, as the year of the Olympic Games increases, the gold medal winning time for men decrease. So it seems to me like there is a relationship. The dots going down here is not by chance, really. It's clear that the dots are going down. So this is how scatter plots can be used to uncover relationships between two variables. And we're going to go through more examples of this further on. So scatter plots can be used to visualize any potential relationship between two variables. Okay, now this potential relationship we would call correlation. So if there's a pattern in the points on a scatter plot, we can say that the two variables are correlated. So when the dots are going up together, we call that a positive correlation. Whoops, positive correlation. Now, just like our example, if the dots are going down, we would call that a negative correlation. And then when the dots kind of are seemingly all over the place and it doesn't appear to have a pattern, we call that no correlation. Okay, so in positive correlation, when one variable goes up, the other one goes up with it. In a negative correlation, when one goes up, the other one you see is going downwards. And no correlation, there is no pattern between the two. So the line of best fit is a very useful tool that we use to not only visualize, but we're going to use it to make predictions. So here's some made-up data about money earned versus hours worked for a waitress. So here are some hours worked, and here's money earned. So normally, of course, the more you work, the more you earn. But here's the pattern of the dots. Now you notice here, though, that we've got this one dot that's seemingly out of place. It doesn't really quite fit with the rest of the dots. We call that dot an outlier. Okay, it is and that is a point that doesn't follow the pattern. Okay. Now, right now I'll ask you to just ignore the outlier. Because maybe that's a one-off thing. This person worked an hour and a half and made $100. Maybe they got a really really great tip or something. As you'll see later on, if you study data management, you'll come up with some rules about whether you should include or exclude an outlier. But right now, we're going to just ignore an outlier and look at these dots over here. So as, I mean, when I see the dots, I can see them going upwards like this. So I can try to kind of trace along and then draw a line like so. So it's, again, there are some dots above the line, some dots below the line, and that's fine. But it goes in the same direction as those dots. So from looking at this pattern, what is the relationship between money earned and hours worked? Well, more hours worked, okay, leads to more money earned. Okay. Now, from this trend, how much money would a waitress earn working 5 hours? Well, we can use the line of best fit for that. So for working 5 hours, I'm going to go to where hours worked is, which is right here. I'm going to go up until I hit my line of best fit, and then I read off how much money that is. Okay, so that's around, it's a bit less than 70, so I would say something like $60, $67, I suppose. Okay. So we use the line of best fit to make predictions. I'm not going to use any dots. We use this line. Okay. So not only does the line of best fit show clearly what the pattern is, but we're also going to use it to make general predictions. Okay, so here's another example of a scatter plot. We're going to relate, here's a plot relating the amount of gas remaining and the time driving in a car. We're going to use a line of best fit to predict. Okay, but first we're going to look at the relationship. So actually, first things first, let's draw the line of best fit. So I notice that the dots are kind of going downwards here. So I'm going to just, I think it looks something like this, and I would draw a line like that. Okay, so again, some dots above, some dots below, that's okay, but it follows the trend of the dots. Now, what's the relationship between gas remaining and time driving? Well, the more time driving, okay, the less gas remaining, Okay. Now let's predict the amount of gas remaining after 3 hours. So again, after 3 hours, I go to where 3 hours is here. I go up to the line, and then I read off the graph. So that's about 30, let's say 32. Okay, and that's 32 liters of gas. Now, how much driving has occurred? If there's 40 liters of gas remaining. So now I'm going to go up to where 40 is here, and I'm going to go to the side, and then go to where the line of best fit is, and then read down, and it's right at 2 hours here. So not only can you make predictions starting from the bottom of the graph, but then also starting from the side of the graph and then reading downwards. All right, now some data can be better fit, not with a line of best fit, but with a curve. So for example, here when we have the number of bacteria over time and days, I can see that there's this really smooth curve that actually goes upwards like that. So rather than drawing a straight line, sometimes it's better to follow a curve like that. Okay? So don't get locked in on the idea that two variables can relate only with a linear line of best fit, but here we can use a curve as well. So I just wanted to show you that example. So anyway, here you're going to give this question a try. Here's a scatter plot relating time studying and grades on a test. What I'd like you to do is to draw a line of best fit and then answer those 3 questions there. So pause the video, give the question a shot, and when you're ready to take it up, just press play. Okay, good luck. All right, so hopefully you see that the line, that the dots are going upwards. So we're going to, I'm just going to trace that, kind of going like this. Okay, so there's some dots again underneath, some dots are above, but it's going in the same trend as the dots are. They're going upward, so this is a positive correlation. What's the relationship between the grade on a test and time studying? Well, the more time you study, okay, the grade on a test goes up, right? The more time studying, okay, the higher the grade. Okay. So relate the two when you're asked about a relationship. Now, predict the mark on a test for someone who studied for 5 hours. So, again, you go to where 5 hours is, and we go all the way up. I'll just put a little dash here. It's going up. So that's about, oh, that's a 76, let's say. It's a 76%. If you got something a little bit, higher or lower than that, that's fine. It doesn't matter. It's, as long as it's close to, where 76 is. Predict the time studied for someone who received a grade of 85%. So let's go to where 85% is, and that's 90 here. So 85 is over here. So we just need to stay in the middle of that row, and then it's probably right about here. So I want to look down, and that's between 5.5 and 6. So let's say 5 3/4. So let's say 5.75 hours. Okay, just to be, I guess, really exact. Even though my line's not exact. But at least we're using the line properly. So that's how we use the line of best fit, not only to show the relationship between two variables, but also to make some predictions between the two variables. All right, so that's it. Thanks very much for watching.